about this episode.
Live.
Okay, let me check. Yeah, we're live.
Okay. Hello, everyone, and welcome to today's episode of Courtcast. I am your host, Tim.
This is Sahil. Welcome everybody to a brand new exciting episode of Courtcast. Before we get started, a few logistical things. If you haven't already, do join our Discord channel. And if you're watching on YouTube, where we do this every Tuesday, 5 p.m. Pacific, 8 p.m. Eastern, do ask us questions during the episode and we'll get to them. So without further ado, let's get to it. So Tim, there's been a lot of like a not a recent wave, but over the past several years, waves of movies and sci-fi that's explored the multiverse more. And so it's entered definitely into the popular zeitgeist. And want to use this chance in this episode to really break down what the multiverse is and what the implications are, and have a more grounded discussion of it. So, when I typically hear about multiverse, I think about the notion of parallel worlds. Like there exist these, alternative universes where if I had like done something else, this would have happened, and I would have like say become like a doctor or in some different industry, or maybe yeah. So I want to clarify, like when we talk about multiverse, what does that actually mean?
Yeah, I think the concept multiverse encompasses many, many different concepts. It started from probably like the ancient Greeks who wondered, is this the only world that exists? And of course, since then, we've realized that we are just one of many bazillion tiny planets in this universe. So I think we can safely say that there are probably many worlds like us. But of course, the needle has moved, the standard has moved, and I would say in modern physics, the notion of a of the multiverse first probably came from quantum physics, when people talk about wave function and how to understand that. And the Everett, I think, popularized one interpretation called the multi-world interpretation that says that, hey, look, it's not that the what the wave function represent is just all versions of reality playing out simultaneously, and we are only privy to one of them. And this is sort of the beginning of the multiverse idea. But but here, what we're really talking about is the notion of parallel worlds. I think we're going to distinguish the two. For us, parallel worlds are not multiverses, because parallel worlds lies in the realms of metaphysics a little bit. It has to do with interpretation, and it's not physical in that sense. Really, the modern idea of multiverse come from when physicists developed this idea called inflation. We'll get into that later. What it tells you is that if space is able to stretch, like what Einstein said, it may be able to stretch so much that it creates almost multiple copies of it over and over again. It's almost like pizza dough. You just take a piece of pizza dough and stretch it out, and and since then it has become a serious contender on what reality actually looks like. And I think that's the version of multiverse that we're going to focus on.
Yeah, that sounds great as a segue into our discussion. So I wanted to start off by, you mentioned the word inflation. We've talked about it a number of times, in past episodes. So for interested viewers, check that out. But can you give our listeners I guess like a bird's eye view, or whatever is relevant for this discussion, of what inflation is?
Yeah, the inflation, it's an idea that is used to solve many problems. But probably the most important one is called the cosmological flatness problem. Um, Actually, I don't exactly know if that's the right name for it. But anyway, the issue is
Mhm.
that the universe looks too uniform. It's almost like, I guess, if you like the pizza analogy, like if our universe is a big piece of pizza, like I don't know, pepperoni pizza, and we're just in the middle of the pepperoni pizza. Like it seems like the pizza is too uniform. It looks the same everywhere. And if you think that as the universe expands, different parts of the universe pizza could easily cook very differently, or might have different ingredients too. How come it all looks the same? The solution called inflation tells you that, hey, look, maybe the universe is born from the same dough, basically, and it's just got all stretched out. And so that's why it looks all the same, because it's one big pizza. So that's sort of the initial idea of inflation. There's this great stretching period that created the dough of the universe, I guess.
So I want to describe like what exactly is stretching. Is it just space that it kind of just visualize it as it's like this bubble and it's just being stretched out really, really quickly. Or how can I visualize it?
Yeah, and this is also called Einstein's greatest blunder. In Einstein's
Mm,
equation, there's a term called cosmological constant, and which is you can loosely thought of as the energy within space itself. And the interesting piece of that is, unlike all the other terms in the equation, the sign can be both positive or negative. Gravity attracts, so a lot of times gravity kind of pull things together. But no, but
mm,
this term can have the opposite sign, and it causes it to kind of anti-attract, I guess, to expand, to stretch out, and that's the piece that we're talking about. It's from Einstein's equation. We realize that space can stretch, and this
mm.
stretching can actually be linked to some other phenomenon. There could be a thing that causes the stretching.
So I just want to make sure I'm very clear on this. There is a clear distinction, at least in my mind. Please correct me if I'm mistaken at any point,
Mhm.
between gravity and this like quote unquote anti-gravity. Is that like gravity doesn't necessarily contract? I don't know if it necessarily contracts the space, but you have like two objects, and let's say they're really massive and they're not moving relative to each other. They'll like go towards each other and eventually crash. Whereas like this is the actual space itself expanding. Is that fair assessment or yeah.
You can think of it this way, but I think the best way to think about it is that gravity can both contract and expand. And this is fully a prediction of Einstein's theory. If you only know about Newton's laws of physics, this will be crazy,
Mhm.
right? Like objects attract, how the hell are they going to repel each other? But through
Yeah.
Einstein's theory, it can be made consistent. And in fact, I think I don't know if this is correct. If you try to make Newton's theory like repel, you probably run into some problems, some mathematical inconsistency. But because Einstein's theory is based on geometry of spacetime, and if you think of geometry of spacetime as like pizza dough, yeah, then it should be able to stretch and shrink. It is malleable, and stretching is just an option that Einstein's theory takes full advantage of.
Okay. That makes sense. I mean, I was thinking about in terms of, Newtonian and thinking about, I mean, we're gonna have to get into this, but like the concept of negative mass, but that's a whole separate discussion. So that luckily that's not involved here. This is literally the geometry of space, and depending on that, will tell you whether it's expanding, contracting, or just staying the same. Is that a fair assessment?
Yeah, yeah, and loosely saying, it can be thought of as associated with negative mass. Of course, when you see a negative mass in the equation, it doesn't literally mean the mass is negative. It just means
Mm,
that you need to interpret the equations differently. And in
mm,
particle physics, when you see a negative mass, it means that there's an instability. And sometimes that instability can feed back onto gravity and cause it sort of like a runaway expansion. And this is sort of what the theory of inflation does. It says that there is some field, which we covered in previous episode, and so we're not
mm,
going to go too much into details on. There's this field called an inflaton, and it sort of has a runaway energy, a negative mass, if you like.
mm,
It's very unstable, and that's why
mm.
it feedbacks on gravity, and it causes it to expand rapidly, exponentially so.
Mm.
And that's the theory of that's the driving force of the inflation. If you like, this is the hand that's stretching the dough.
Yeah, that makes sense. Also, explains why I've heard the universe isn't necessarily in a stable state. So, we've covered what inflation is, essentially the stretching of space. Does that also include time, or is that, I mean, can I only think about this in terms of space? Like, what about relativity that connects space and time? Like, yeah, are those connected to each other?
Right, yeah. One has to remember that imagine you have a space time that's stretching so fast and it
Mm,
gets so big so quickly. And this stretching can be faster than the speed of light because it's just
mm,
space itself. Um,
mhm,
then what happens is one part of the space time can become completely disconnected with a different part, right? In
mhm.
some sense, the two different parts can stretch differently now. There's no reason they have to stretch at the same rate. So now we kind of have so I guess the pizza analogy is not totally apt. It's like imagine you stretch out the pizza dough a lot, and some of them might stretch at a different rate, and some of the dough might break, some of the dough might clump up a little more, and each little pockets will start to develop different properties now.
Yeah, if I'm to channel my inner Mikey, oh wait, Tim, I think you might be muted, or you're not muted. You can hear me, right?
Yeah, I can hear you.
Oh, okay, sorry, never mind. Forget about that. Um, so if I'm just channeling inner Mikey, I believe he would say that like it's not just that the pizza dough is stretching, but that the density of dough stays the same as you stretch it as well. It's not that it's like thinning out. Is
Yeah,
that
yeah,
right?
that's
Or
probably true. Yeah, the pizza dough analogy is not perfect. Keep that in mind. It's not pizza dough is not space time. It's not the best analogy, but you know.
yeah. I want to touch upon this, and then we can go to how this connects in multiverse. But what does it mean for like the time aspect, like to sort of stretch out? Like how do I view the stretching of space connected with time? Is it
Yeah,
that like
I mean,
yeah, okay.
certainly stretching of time also happens, but probably it's harder to visualize. Stretching of time, the result of it is gravitational force. Uh, it, but the way objects slows down or like less versus more, it essentially leads to acceleration. So stretching on compression or extension of the time dimension is associated with gravitational attraction itself. But it's sort of hard to visualize. But but one thing I would say is this stretching because now our universe is so not uniform now. So in some places it's
Mm,
like the dough is really thin. In some places the dough
mm,
is really dense. The notion of
mhm,
time at each instances is different, basically. If you have aliens living on this patch of the universe
mm.
versus the other patch, you can't really tell time because they don't really communicate. But if you insist on having a bird's eye view, which is not possible, by the way, but if you do
Mhm.
insist that, you might see that the time over at one part of the universe is way different from another part of the universe. It's just totally different.
So is it kind of like the way I think about it that as you have space-time itself expanding, just like there can be like I guess I don't know if I want to say more variation, but just more space. There are more like ways in which time can be different in these like different parts of the expanding universe that are disconnected from each other.
Yeah, yeah. I mean, you can think of it as I don't know if that's a good analogy. It's almost like a like it's almost like a little echo chamber. I don't know if that's an Apple analogy. Imagine you have small variations in your original universe. Let's say universe A has some small slight differences with universe B, right? As
Yeah.
they expand, they become so far apart. And now they can expand
Mm,
independently. Now they can evolve independently. And universe A might
mm,
evolve to having certain properties, and universe B can evolve into having totally different property, totally different notions of time and
mm.
physical constants even, and then different evolution. So everything could look different. Like one universe might have galaxies, the other might fail to have galaxies because of other nuances in the creation of the universe.
Yeah, yeah, yeah. So, actually, last point I'll make about this, and then we can move on to the multiverse. So, I heard an interesting explanation from Professor Susskind, who's a Stanford professor, very famous in in this field. And he was talking about how you can even like bring it more down to earth and view like just like different ecosystems evolve differently. It's similar to like, as you were saying, Tim, these universes evolving differently. So one patch of earth you have rainforest, another patch of earth you have desert, and they kind of evolve separately. I mean, even though they're causally connected to each other and in principle can communicate with each other, it's just biologically might as well be in separate areas, like distinct from each other.
Right, but I would say
So
it's much more dramatic though. Like this is much more dramatic. Like previously we talked about like the Higgs field could destroy the entire
yeah, yeah,
universe, for example.
yeah, yeah.
But here, in different pockets of these little universes, for example, the Higgs field could have very different value. One,
Mhm,
in one of them, maybe by chance, the Higgs field could have
mhm,
values that are okay for life to and galaxies to exist. In the other one, maybe the Higgs field is so heavy that you just see black
mhm,
holes with no galaxy, nothing, right? And in the
mhm.
third one, it might just be unimaginable. We don't even know what the universe looks like. It's just so crazy that strings or whatever, if string theory was correct, like so it would be so dramatically different. Not even
Y-
can't even imagine.
Yeah, absolutely. I don't disagree with that at all. I mean, this is like a watered down analogy of like of what you were talking about. Yeah, because in biology, at least on Earth, same laws of physics. So, and most creatures share like similar structure of how they evolve, DNA and whatnot, and in different universes be very different, unimaginable to me at least. I don't know about you. Um, so yeah, so now I want to transition the conversation to the multiverse, and in particular, we've talked about inflation and what it is, and I wanted to understand what I guess like how is inflation, this stretching of the universe, related at all to the concept of multiverse? I mean, when I think of multiverse, I think of like the parallel worlds, but you're mentioning it's very different than parallel worlds. So let's kind of tie this all in together.
Yeah. So first of all, like parallel worlds is an interpretational issue.
Mm,
But if you want to interpret quantum physics literally, you could think of it as a real thing. Like for example, imagine if my fingers were quantum mechanical, and like let's say I have Schrodinger's hand. It could be my hand could be to the left or to the right, and then
mm,
all of a sudden I see my hand is on the left, and then I ask the question, well, what happened to the possibility of my hand being on the right? Remember, there's a sacred laws of quantum physics that says possibilities are conserved. Like even though I observe my hand on the left, my hand on the right, that information associated with it's not removed. It's still there. The parallel world interpretation says that hey, maybe there is kind of a universe privy, like a parallel universe where my hand was on the right, but we just didn't experience that. Of course, if we did experience that, we'll just be talking about that. And if you believe that that's like a real universe, these universes are very similar, although disconnected. Like a little. Of course, their differences will diverge, right, over time. Because if my hand's on the right as opposed to on the left, maybe I will buy the lottery and become a billionaire. Whatever. Um, so and those worlds might diverge, but they, in some sense, they're not physical. Like just because they exist, it doesn't necessarily impact the way the world works, right? But
mm,
And this is different from the physical multiverse idea, which is not interpretational.
Mhm. Interesting. So, okay, so parallel worlds is definitely interpretational based on quantum mechanics, the many worlds interpretation. And what we're going to talk about is actually not necessarily interpretational, but arises from inflation itself. Is that fair to say?
Yeah, yeah, and the thing is, I mean, you do need something like inflation, although other possibilities are possible, but let's just stick to inflation.
Mhm.
You need a mechanism to produce more universes. Like imagine sure you have this thing like Higgs field, you have all these physical properties, but you don't have inflation, let's say, right? Then
Mhm.
you only have one universe. You only have one
Mhm.
pizza. There's no stretching of the pizza, right? Like what you see is what you get. Like there's no
Mhm.
making more universes. But the moment you have inflation, even if you
Mhm.
start with your one universe,
Mhm.
let's say you're God. I mean, I don't like to use this term, but let's say you're God. You try to only make one universe. You're like, forget about inflation. I only want to make one universe, right? But
Yeah.
the world is quantum mechanical. There is a chance if there's an inflaton here and that's unstable, there's a chance it can decay. Remember previous episode,
Mhm.
you can have something like the Higgs field, something that is metastable. Even if God tries his or her damn hardest, quantum physics will cause pockets of the universe to decay, and all of a sudden expand and run away and create another universe. It can stretch into more universes. So not even God can stop it. So the moment you put in mechanisms of inflation, although let me just say, not all inflation models give this,
Mhm.
but specifically what we call eternal inflation models, where this force is really unstoppable because in the universe you have basically infinite time. Eventually, it creates more
Mhm.
universes. So when you let that happen, I mean, you basically open Pandora's box, right? Like
Mhm.
you can't help but like the universe can't help itself. It's gonna make more. So
Mhm.
multiverse, if that is true, then multiverse will definitively exist.
Yeah, so actually, I want to kind of take a step back and ask another really basic question is, what is the definition of a universe? Because if you say something, there are multiple, like it's just creating more universes. What does that mean? Like, yeah, I just want to understand that more.
I would say that the definition of a universe is actually not that sharp, right? Like, so we have our observable universe. It just means
Hmm.
that we can only see so far. So that's kind of our universe, and we can never see further because of the accelerated expansion of the universe, right? The universe is
Hmm.
getting bigger and bigger. Like things that are really far away, we'll never be able to reach. Okay,
Hmm.
so for us, this is kind of our universe. Of course, for
Hmm.
you have a slightly different universe. The boundaries a little shifted because between you and I don't know how many 100 miles, right? But
Yeah.
but each one of us kind of has our own little personal universe, kind of. But the majority of it is intersecting, right? 99.99999. How many nines of
Yeah.
yours and our universe are intersecting? But of course, if you go to an alien on Andromeda, that intersection might be a little smaller. But if you keep going further and further and further and further, eventually there could be pockets of, I don't know, imagine they're aliens, let's say, so far away. Eventually their personal universes and our personal universes will never intersect. Then
Hmm.
we'd say that these are totally different, distinct universes. And then you might literally have these universe boundaries, right? In previous episode, we
Hmm.
talked about these cataclysmic events, right? Like the Higgs field
Hmm.
could have one value over another value, right? The proton mass could be one value here versus the other value here.
Hmm.
And then there are these boundaries where one side of the boundary, you have one possibility, and the other side of the boundary, the other possibility. And where the boundary is going on could be very, very violent, like cataclysms are traveling and fighting
Hmm.
against each other. But then away from these boundaries, yeah, you have universes with different properties. So that's what we're talking
Hmm.
about.
So okay, so just to make sure I understand what the definition of universe is, if I define me as, I mean, this is very, might sound narcissistic, but if I define myself as the center of my own universe, whatever I cannot reach, like causally, meaning if I were to send like a signal of light and you were far enough away, you're moving by pure fact that space itself is stretching, as you go further away at a faster and faster rate. So eventually it'll reach a point where it's stretching faster than light. I would consider you to be in a different universe than me because there's no overlap between you and me in terms of like the light signals that we could send to each other and ever contact each other. Is
Yeah,
that another?
at least conventionally, right?
I
Conventionally,
see.
you cannot contact each other by
Mm.
sending simple light signals. But there may, maybe there are other ways, but conventionally, it's not possible.
And so conventionally, you could view I mean, I don't know if it even exists or what's in it, but uh, if I were to surmise the inside of a black hole versus the outside of a black hole would be in two separate universes in some sense, right?
I
Or would you
mean,
say,
you can sort of view it like that, and this is where the intriguing part comes from, right? Like
uh,
you can think of the inside of a black hole as kind of a different world. And of course,
mhm.
if I mean, now we're going into speculative territory, right? Like we don't know what's inside of a black hole. If you go
Oh,
inside, if you go inside the black hole, it ends. Well, okay, then the inside the universe inside the universe sucks. Inside the black hole sucks. It's just a bad universe, right? But I mean, if you have watched Interstellar, you know that there is a plausibility where in goes a black hole. You might have an exit, kind of like the inverse of a black hole, that comes out somewhere. And this is called a wormhole
mm.
solution. And maybe you can exit to a different universe, and that could be a way to explore the multiverse. Very speculative, though.
Huh. Yeah, no, that, that sounds really, really speculative. Um, and then okay, so overall the concept of what you're talking about is points in space that are causally disconnected, meaning that if I send a beam of light or try to send information at the speed of light from one point to the other point and can't reach because I'm expanding faster than light away from that point, those constitute separate universes. And the boundary is a
Mm.
little bit fuzzy of like what that actually is.
Mm.
And because space itself at region inflation causes space to expand at ever increasing rates, depending on how far away you are from whatever relative point you're measuring to, it will thus create these physical multiverses because of the fact that space is expanding faster than light at certain distances away from, let's say, where you are.
Right. Yes. So, and at least we think they are physical. Although some people have argued that if you can't
Mhm.
scientifically test it, is it physical or not? Um,
Y-
but that's up to
Yeah,
debate a little bit.
I was yeah, no, that is a fair point. I guess well, so we're almost at time, and so I want to ask you one quick lightning round question and then we can end the episode. Is as the laws of physics different in these different physical multiverses? So for instance, like the gravitational constant, the speed of light, those sorts of things, are they different as you if you were to go like far enough away, or do you think they stay constant?
I would say there's two views on this. I would say the
Okay.
true laws of physics, physicists believe are the same.
Okay.
But the question is, do we know the true laws of physics? If we don't,
Mhm.
our laws of physics might be a happenstance. Just kind of like, just kind of like the distance between the Earth and the Sun. You can think of that as
Mhm.
the laws of physics. We are, I don't know how many billion kilometers from the sun, or million kilometers from the sun. You can think of that as the laws of
Mhm.
physics, or it's just an accident. So if you take that view, our laws of physics, which includes the Higgs field, quarks, and electrons, and all that, could be a result of coincidence almost. If that's true, then it means that this laws of physics could be different in elsewhere.
Mm.
because our laws of physics are not the true laws of nature. So in that
Mm.
way, um, my personal belief is, yeah, probably our laws are not really the true laws of nature. Probably it's just part of it is accidental. So I imagine if multiverse is real, those laws, will be different.
Yeah, yeah, yeah. And so we're almost at time. So I wanted to give you a chance, in our tradition of leaving the audience with any words of wisdom that physical multiverses have taught you, as opposed to the parallel worlds.
Yeah, I would say one takeaway message is that you think about the history of the philosophy and physics. It has come a long way. We used to believe that we are the center of the universe, right? Like we people used to think that the sun revolves around the earth, right? But slowly, it seems like every step along the way, we are always more and more humbled. Like even the solar system is not unique, even our galaxies is not unique. They're bazillion, and I think it makes very much sense to think that even not even our universe is unique. And the thing is, the moment you allow the universe to create more universes, it is inevitable that it will create more because time is infinite, and quantum physics
Mm.
is in some sense the most powerful force in the universe. Anything that's possible, eventually it will get to it. And so, if I were to place my bet, we may already be in this infinite ocean of multiverse. And maybe I don't know. Is there a next level up, like a multiverse of multiverse? I don't know. Maybe it ends here. I
I
think.
mean, yeah, so I'll just chime in on that. I mean, not physical multiverses, but there's a book called Our Mathematical Universe. Talks about the mathematical universe hypothesis and talks about different levels of multiverse. So what you just described was like level one, level two. There's a level three and level four, but I don't want to get. I mean, we also talked about that in a past episode a while back. So for also
Right.
interested viewers, do check that out. Yeah, so there, I mean, there is something that goes beyond that where you can say, oh, all possible mathematical structures itself, computable mathematical structures can be considered universes. But anyway, yeah. So on that note, I want to thank everybody for joining us, and we'll see you all next week.